For this set of tasks, you are in charge of completing each table so that a single line does contain all of the points that are given in a table. So because we know that we do have a single line, then we can use some patterning skills to fill in the rest of the blanks. In this first table, the x's proceed 3, 6, 9, 12, 15. Each time you move down the table, you add 3. That means that if you're going to have a linear relationship, then over here in the y column, we need some kind of consistent addition or subtraction pattern as we move down the table over here. To go from 12 to 4 with either addition or subtraction, we would need to do subtraction, and we will subtract 8 to make that happen. Once you have that part established, then you can keep subtracting 8 to fill in the remaining 3 blanks. 4 minus 8 will be negative 4, minus another 8 will be negative 12, minus another 8 will be negative 20. Things get a little stickier in a table like this when the y values are not right next to each other. We should take a look at the x values first, however. The x's, 3, 6, 9, 12, and 15 again, the x's are all going up by 3. Then what I do for these is I compare 12 to 4. So 12 minus 4 gives me 8. And then I consider how many steps it takes to go from one completed entry to another. So I start here like on a game board, and I think about, oh, it takes 1, 2, 3, 4 steps to get to here. So I do the jump of 8 divided by 4 steps gives me 2. And because 12 decreases to 4, I'm going to subtract 2 each time. Let's see if that works. 12 minus 2 is 10. 10 minus 2 is 8. 8 minus 2 is 6. And then if I do the next one, 6 minus 2 would be 4. And so this is almost self-checking when you do the work. We can do similar things in these middle 2 tables. Let's see what's happening in the x column in this one. From 5 to 10 to 15 to 20 to 25. Looks like we add 5 each time. This one has a gap between the entries for y. So 43 minus 13 is a gap of 30, thinking on the number line. And then if this were a game board and you started here at the 13, it would take 1, 2 steps to get down to 43. So I do 30 divided by 2, which is 15. And since we're growing from 13 to 43, I will add 15. 13 plus 15 will give me 28, and then 28 plus 15 gives me 43. So I know I've done this direction correctly. When I went to get these other 2 blanks above the 13 in the table, I'll subtract 15 as I move upward in the table. 13 minus 15 would be negative 2. Negative 2 minus 15 is negative 17. And that one is done. In this table, from 2 to 5 to 8 to 11 to 14, I think we are adding 3 each time. The y coordinates that we know are right next to each other in the table. Since we have a beautiful addition pattern over here in the x's, to have a linear relationship, we'll have to have either an addition or subtraction pattern in the y's to make it consistent. That means we're going to need to do subtract 7. 0 minus 7 will give us a negative 7. And then we keep subtracting 7 all the way down. Negative 7 minus another 7 is negative 14. Minus another 7 is negative 21. Minus another 7 is negative 28. The last 2 tables have slight twists in them. If you admire these ahead of time, you might notice all the blanks are on the x side in this bottom table here. And then on the y side, it doesn't look like there's a great pattern emerging. 12 to 5 to -7, 3.8, 126. So this can be a little bit intimidating, but when you look in your x column, both of these x's are 3's. And that means the rest of them will need to be 3's. And you might be wondering how this goes with the consistent addition or subtraction pattern idea. It's a little bit of a twist. So what happens here, if you think about plotting these, your x is always 3. So in your graph, you would have an x value of 3 and a y value of 12. You'd plot 3, 5, 3, -7. And when you do that, you'll get a vertical line. And you know from your work with vertical and horizontal lines that they behave a little bit differently compared to other types of lines, the oblique lines. So this ends up being a vertical line. When you have x's that repeat and they have different y values, and we're talking about a linear relationship, that means that we're talking about all of the x's being exactly the same value. A similar thing happens over here in this table. It looks like the x's aren't behaving very well to talk about a linear relationship, and then you notice that the y's are both equal to 12. And that's going to indicate that all of our y values are going to equal 12. And when all of your y values match, that means that you have a horizontal line. These last two have a little bit of a twist with them compared to the others on this page.